right. Hello, welcome to today's webinar on updates to the 2021 Seattle Existing Building Code and Seattle's steps towards recognizing retrofitted URM buildings in the code. This will be a technical briefing intended to accompany yesterday's programmatic webinar. This presentation is being recorded and both audio and video and will be posted to the city's URM website afterwards. If you have any questions during the webinar, feel free to open the chat window and submit your question. We'll hold off on answering questions until the end of today's presentation. At the end, we'll also provide an opportunity to unmute microphones and ask questions directly and engage in conversation. Closed captioning and translations are available for today's presentation. To enable, navigate to the lower left of your screen and click on the speech bubble. Clicking the little caret next to it will allow you to select different languages for the translation. So first, a few introductions. My name is Derek Olgren. I am the URM program lead engineer at SDCI. I've been here for just a few months, so still getting associated with the department. I'm also a senior structural plans engineer. My previous experience, I have about a decade of experience in structural design in Seattle, focusing on seismic retrofits of existing buildings, many of them URMs. Prior to that, I was a carpenter in Tennessee working on adaptive reuse projects in existing buildings. Many of those were also URMs. And I'll let Amanda, our program manager, introduce herself now.
Yeah. Good afternoon, everyone. Happy Shakeout Day for those of you that participated in practicing your drop cover hold on. My name is Amanda Hertzfeld. I am the URM program manager here at SDCI. I've been here about 2 years and I'm leading the development of our retrofit policy as well as our financial incentives.
Thanks, Amanda. So we'll start with the agenda. Our goal for today's meeting is to review the 2021 Seattle Existing Building Code adaptation, recognizing URM retrofit minimum standards, and to provide opportunity for questions. So we'll be talking about some changes to the 2021 SEBC, as well as the URM retrofit definitions, what a minimum standard is, and the methodology required. And then there's also some modifications to the triggers for substantial alterations. We'll also cover some updates to the City of Seattle URM database and some new documents for procedures to demonstrate retrofit status of a URM building, and also how to appeal a URM designation of a non-URM building, including URM buildings that have been demolished. Before we start, I just want to acknowledge the hard work that's gone over for many years by the URM task group. You can see on this slide, this is just the most recent selection of engineers that were on the task group. And there's a broad depth of experience from practicing engineers, both structural and geotechnical. It's been a highly collaborative effort between the city and the private sector since at least 2008. So a lot of the why of retrofitting was covered in yesterday's policy presentation by Amanda. If you missed it, a recording of that presentation will be viewable in the URM program website. Seattle has over 1,100 URM buildings, and we estimate that only around 15% of them have retrofits that are compliant with the 2021 SEBC retrofit compliance criteria. URM failures are a hazard to both the residents of these buildings and the general public. This is a video of a quarter scale shake test demonstrating a few of the common failure modes, such as a soft story collapse, pier rocking, and out-of-plane wall failure. And that is also with the relatively low accelerations. So first, what's included in the new URM seismic regulations and other code changes? First, there's an official definition of what's required to be recognized as retrofitted on the city's URM database. Meeting this definition is currently voluntary, and the definition creates a pathway for designation on the city's database as retrofitted and will incentivize voluntary retrofits for building owners with capacity to retrofit. This is all before we would hopefully move towards mandatory retrofitting in the future. Second, the code changes include the identification of previous retrofit dates that are eligible to be recognized as retrofitted, pending their submission of an engineering report to SDCI. Third, the codes formally establish the alternate method as a code-compliant retrofit. SDCI has already received permit applications for a small number of URM retrofits using the alternate method under Director's Rule 6-2023. And finally, the URM specific subalt trigger number 5 has been moved and changed to meet the lower standard. And I'll read the first line on this slide that compliance with the new seismic regulations is voluntary at this time. The goal of the recognition of URM retrofits is in the code is to encourage voluntary retrofits and to give reassurance that any voluntary retrofit completed now will comply with the mandatory URM retrofitting requirements in the future. A voluntary retrofit work of any scope does not count towards triggering substantial alteration. However, any additional scope such as MEP upgrades, energy efficiency upgrades, or general remodeling may still trigger a subalt when done in conjunction with voluntary retrofit work. Now, I'd like to emphasize that the alternate method is a lower, minimally acceptable standard than a substantial alteration. The architects, engineer, and construction community needs to be on board with communicating this to clients and owners. And I'll repeat this a few times during the presentation, that the alternate method is not a replacement for a full code retrofit when triggered by the subalt. So this flowchart summarizes some of the changes to the 2021 SCBC as they relate to URM retrofits. There are new definitions in section 202 and a new section in chapter 3 with the size regulations for URM buildings. Additionally, there's a new appendix A6 that covers the alternate method. And within the section in chapter 3, there are 3 compliance pathways defined. There's the code-based retrofit, which is the equivalent to the seismic requirements required for an SCBC substantial alteration, and that section is unchanged. Second, there's the alternate method retrofit, which is codified version of Director's Rule 6-2023, and similar to the Bolts Plus retrofit methods developed in California and previous tech standards that have been published by the Technical Committee in Seattle going back to 2012. And then the third option is benchmarking, which provides a recognition pathway for previously permitted and completed retrofits. On this chart, the retrofit recognition methods that are new to this code cycle are in red boxes, and the existing retrofit methods are shown in gray. And we'll follow along with where we're at in this chart in the top right corner with a little yellow highlight to kind of help guide us and keep track. So we'll start by covering the general definitions that are in section 202. First is the definition of unreinforced masonry, or URM, and that includes burned clay concrete or sand lime brick, hollow clay tile, or hollow clay block. Notably, this definition does not include concrete masonry units, also known as CMU. We've determined that unreinforced red brick masonry was identified as the most vulnerable in a seismic event. Second is the unreinforced masonry building, which is a building where one or more URM walls provide the primary support for vertical loads from the floors or roofs, and the URM walls rely on the tensile strength of masonry units, mortar, and grout in resisting design loads. And this applies to any load-bearing wall, and only one load-bearing wall needs to be present in order for it to be classified as a URM building. And this is not notably applied to infill walls. And URM buildings were generally constructed prior to 1945 after seismic lateral bracing requirements were introduced to the Seattle Building Code in 1942. And they're ruled unlawful after adoption of the 1973 Uniform Building Code on May 7th, 1977. The final and most important definition that's new to the code is for a retrofitted unreinforced masonry building. A URM building that meets a minimally acceptable level of life safety risk from earthquakes by demonstrating compliance with section 304.5.1. And retrofitted buildings are eligible for a status change in the City of Seattle URM database. The database is available on the City of Seattle SDCI URM program website, which has recently been updated, and the list is available there for viewing and will be moved over to GIS systems in the near future for better visualization. So we'll talk about the change to the substantial alteration triggers for URM. So we're getting rid of the infamous subalt trigger number 5, which is a significant increase in an occupant load of a URM building. As a department, we think that URM buildings retrofitted to comply with code changes should no longer be penalized more than any other type of structure since the hazard is now mitigated. While this change will result in some URM buildings not receiving the non-structural fire and life safety upgrades that would other be required per the sub-alt trigger number 5, this is considered acceptable because definition number 5 only existed due to the high seismic hazard of URM buildings. And if the scope of work meets definitions 1 through 4, a sub-alt will still be triggered regardless of the type of structural system still in the building. And a new trigger specific to URMs only is added to one of the new code sections to cover the lower retrofit level that's now required in order to meet compliance. And I'll repeat again that retrofitting to the minimum standard does not relieve the owner of substantial alteration requirements when triggered by other rehabilitation work. The alternate method is not a replacement for a full code retrofit when triggered by a sub-alt. Okay, now that we've covered the key definitions, we can dive deeper into the main content, starting with section 304.5 and its subsection. So item 1 in 304.5 replaces the previous sub-alt trigger number 5, and it still gives the building officials latitude to require retrofit of the building when the occupant load is increased, but only requires retrofitting to the minimum acceptable level of life safety risk. Number 1's a relaxed requirement compared to the previous sub-alt trigger while still targeting URM specific vulnerabilities. And then item 2 covers any building where the owner voluntarily wants to be recognized as a retrofitted building. Once the potential sources of funding that Amanda alluded to and covered in her presentation yesterday are worked out, the voluntary language in this section will be changed to mandatory. So going forward, after the 2021 SEBC adoption date on November 15th of this year, new permits for URM retrofits will need to comply with item 1 or 2 of this section to be recognized as retrofitted. We will still be accepting voluntary retrofits with a reduced scope of work, but they will not be recognized as retrofitted on the list. In this section, item 1 is the reduced IBC forces retrofit that's required when a building is determined to be a substantial alteration. It can also be used voluntarily for compliance. Item 2 is the alternate method, which provides a path to compliance with a reduced scope of work and a lower level of life safety risk. Item 3 applies to all buildings with retrofits permitted prior to the adoption of the 2021 SEBC. Item A is for subalts permitted between 1996 and 2009, and item B is for subalts permitted after April 24th, 2009. Item C will be for any other previously completed retrofit, voluntary or otherwise, that may be in compliance with the intent of this section. So that could cover anything from a earlier subalt that meets a greater code standard than that was typically followed at the time. It could be a DR6 2023 or something that followed one of the earlier technical standards. And we'll get into the specifics for each of the compliance methods and the reporting requirements for previously completed retrofits later in this presentation. The first option for compliance with the seismic regulations is item 1 of 304.5.1, which references section 304.4.2, and that section itself is unchanged, but it's now referenced as a recognized retrofit method for compliance. These are the same procedures followed for substantial alteration, and since that section is not new, I'm only going to spend a short amount of time covering it. Section 304.4.2 is the same standard as buildings undergoing a substantial alteration and must address a comprehensive list of common deficiencies. Retrofit design typically uses forces of around 75% of new buildings. However, there's a change in the 2021 SEBC that the previous 3/4 reduction on BSC 2E following the ASC 41 procedures is no longer allowed. And this is to bring the forces for those retrofits into this kind of the same category as using 3/4 IBC forces or Appendix A1. The retrofits typically use a series of checklists to determine where to target the retrofit efforts and identify deficiencies. And they typically include a new or strengthened lateral system, wall bracing, wall anchors, and floor and diaphragm strengthening, including cross ties and cords. The section itself is unchanged, and many of the people viewing this presentation will be familiar with it, but it's just now recognized as a retrofit method for compliance, and there are still the same procedures followed for a substantial alteration. So a code-based retrofit typically starts with the 41 checklist and identifies the common deficiencies. Based on the checklist findings, the scope of work often includes a supplemental lateral system, such as a braced frame or concrete shear walls. Diaphragm improvements, including cords and collectors, in-plane and out-of-plane wall anchorage, out-of-plane wall bracing, and parapet bracing. Significant foundation work may also be required depending on the site and geotechnical conditions. The illustration on the left shows kind of the typical scope of work, including brace frames, diaphragm improvements, parapet bracing, wall anchorage, in-plane and out-of-plane, and then also out-of-plane strong backing. And the image on the right is a sample of a typical ASC 41 checklist. This is an example of a code-based retrofit where a new supplemental lateral system was installed along with collectors, wall anchorage, and out-of-plane bracing. It's a good example how significant structural seismic retrofitting can be accomplished with minimum visual impacts to the space. In the image on the right, where the row of five windows is, there's a new concrete shear wall along that wall face that's been completely covered. There's multiple areas of strong backing and bracing all the way around the room, most of which is not visible or noticeable to the people that haven't been informed otherwise. Here's also a couple examples of steel braced frames in different configurations. On the left, there's a two-based frame with diagonal pipe braces that goes up 7 stories. And on the right, there's a chevron square tube buckling restrained braced frame that's set back from the front of the URM wall. The brace frames offer many different configurations to accommodate different architectural demands and maintain things like open sight lines. Okay, moving on to item 2. A new minimum acceptable level of seismic safety in URMs that we're calling the alternate method. The new alternate method is a cost savings method informed by successes in California and is designed to minimize collapse hazards in an earthquake. Buildings retrofitted with this method will still experience damage in an earthquake, but the risk to life and injury is greatly reduced. The alternate method captures the most vulnerable collapse hazards of a building to minimize the risk of injury and death in the event of an earthquake. And the alternate method can be found in the new chapter A6 in the SEBC appendix. And in order for a building to use the alternate method, it must first qualify by meeting a set of criteria. This is currently adopted by SDCI as Director's Rule 6/2023 and generally matches requirements for other Bolts Plus programs that have been in place in California for decades, and also matches the previous Seattle draft technical standards. So some of the requirements are that it's 6 stories or less, with risk category 4 being excluded. There's no weak story irregularities. The mortar shear strength must be a minimum of 30 psi, and testing is required. There is no assumed minimum mortar strength for the alternate method. Wood diaphragms must be present at all levels above grade with no straight sheet diaphragms, and 2 lines of resistance in each direction. So a building with an open storefront may need a brace to qualify. And the wall piers along in each line of resistance must have a height to width ratio of less than 2:1 and at least 40% of the total wall length. If you have less than 40% of the total wall length, then you can demonstrate that the wall piers have a DCR of less than 2.5 for in-plane forces. We added this DCR check as an option for cases where buildings that won't meet the 40% wall threshold. The DCR limit was developed to accept a higher in-plane shear stress compared to Appendix A1 special procedure and was calibrated to 40% of the wall length. Here's an example of a building that may qualify for the alternate method. It's got 6 stories, not risk category 4. It has 2 lines of resistance in each direction, but it may require a brace frame along the open storefront side. And for a building like this, it's possible that the brace frame only needs to go up 4 or 5 stories if the top floors can meet the DCR requirements of 2.5 or less. The alternate method also requires minimum tested mortar shear strength of 30 psi. However, if epoxy or mechanical anchors are going to be used in the retrofit, the minimum mortar shear strength must meet those required by the manufacturer's ICC reports. And depending on the product used, this can be up to 80 psi minimum. So always double check your epoxy and anchors to see what the minimum shear stress is, and if you think the condition of the building can warrant it. And STCI prefers to shear strength testing during permit review, if at all possible, because it helps facilitate progress and reduce holdups down the line. And in general, there are fewer testing requirements than A1 as far as the locations around the building where testing needs to be performed. Wood diaphragms are required at all levels with no straight sheathing. There's some exceptions. Straight sheathing is allowed where hardwood flooring with overlapping edges is nailed over the top. Some other exceptions are where there's cross walls at 40 feet on center, such as in a residential building, or there's very small diaphragms with the span limited to 24 feet and a 2-to-1 aspect ratio. Alike with open storefronts where you can install a frame to meet compliance, the diaphragms can be modified with a plywood overlay, and the mortar can be pointed to meet the minimum shear stress. So here's another example of a building that may qualify for the alternate method, but note that this building might not qualify because the pier to the bottom right won't meet the aspect ratio where it's between the two doorways. And without that, it may not meet the 40% length. And this pier is also a good example of how to aim for practicality when measuring the pier aspect ratios. Use engineering judgment on where the load will be applied and where failure mechanisms are likely to occur. I think for a pier like this, it would be adequate to judge the height to width ratio from probably the middle of the pier height between the two openings. And if the piers don't meet the minimum length, then a shear stress check should be required to demonstrate that the DCR is less than 2.5. Okay, so here's an example of a building that has wall piers pretty much all with a 2-to-1 aspect ratio that make up at least 40% of the wall length in each direction. Note that the narrow wall piers between the two close set windows can be discounted as long as you still have 40% wall length in the remaining piers. Again, we use engineering judgment and be practical with how we're applying loads and recognizing failure mechanisms. This is also looks to be an apartment building and likely has cross walls inside that would help with meeting the diaphragm requirements. So the intent of the alternate method is to seismically retrofit as many buildings as possible in a more affordable manner. The level of life safety and risk mitigation is lower than a full code-based retrofit, though. However, SDCI supports architects and engineers in encouraging their clients to go beyond the minimum standard presented here when retrofitting. For example, you could be pursuing an alternate method and still include things like cross ties and cording the diaphragm without going for a full subalt. And if you do qualify for alternate method, the basic assumption is the building has a basic lateral system. And the intention here is to minimize the cost of design and construction while reducing the risk of collapse and loss of life. And it's now a standalone method fully encapsulated within the SEBC instead of a director's rule. And like I mentioned before, it's modeled after Appendix A1, Bolts Plus programs, and the technical standards, with the 4 critical components being addressed of wall anchorage, diaphragm shear transfer, out-of-plane wall bracing, and parapet or appendage bracing. Now, some of the retrofit methods that would be applied in the alternate method. This is wall anchorage, or in-plane and out-of-plane wall anchorage is one of the critical elements of the alternate method. Positive attachment of the walls to the floor diaphragm prevent the floor from dislodging from the wall in a seismic event and collapsing. Tension tie anchors can also serve as in-plane shear transfer bolts. In the alternate method, the in-plane and out-of-plane forces must be developed into the diaphragm. However, cross-tie connections continuous to the opposite wall are not required. So in the bottom right picture, you can see that there are 4 bays of blocking installed adjacent to the out-of-plane wall tie, and that is to develop an adequate distance into the diaphragm versus just attaching to 1 or 2 bays. So here I have 2 videos showing walls that do not meet the minimum aspect ratio requirements and to demonstrate the effects of out-of-plane bracing. The first video that I'll show has out-of-plane anchors at the floor level at the top, but does not comply with the aspect ratio, and the accelerations are relatively low, 0.46 G. You can see it doesn't take much to get the wall moving and then ultimately collapse. I think that video does a lot better demonstration of what a ton of bricks looks like coming down on your head than the cartoon versions do. And then the video on the right shows the effects of wood stud bracing for out of plane. The accelerations in this video are 1.33 G, so roughly 3 times that of the unbraced wall. You can see that there's movement visible in the bricks, but there's no collapse. So you can tell from the video that wood studs can work quite well to brace URM walls. It's also common to use steel studs or HSS tubing. So out-of-plane bracing to meet the aspect ratio requirements is not always just required due to the height to thickness ratio between floor levels. Other places where bracing may be required are in stairwells or shaft openings where the floor diaphragm is just simply not present. Structural solutions can also be creatively hidden in architectural details, such as the curved strongback around the window frame in the right-hand picture. This is from the church that I showed earlier that had a full retrofit hiding most of the structural elements. Parapets are the greatest risk to life safety posed by a URM building. SDCI considers them unsafe appendages and currently requires parapet mitigation for any construction permit issued in the URM building. There are many options for bracing, including commonly seen steel kicker braces, steel braces with strong backs, and steel rods or fasteners installed vertically, anchoring the courses together. For all bracing types, the forces imposed on the roof diaphragm or the base of the parapet wall must be addressed as well. And again, the basic assumption of the alternate method is that the building has a basic lateral system and all the pieces just need to be tied together. So this is the same illustration that I showed earlier for a code-based retrofit, but here the new lateral system with a braced frame and floor diaphragms are not required as part of the scope of the alternate method, but they can be added to meet the qualification requirements. So typically you would see the parapet bracing, in-plane and out-of-plane wall anchorage, and out-of-plane wall bracing where required. And I will remind you again that the alternate method does not relieve the owner of substantial alteration requirements when triggered by other retrofit work. And though bolts and rosettes are the gold standard for out-of-plane tension ties, historic preservationists may prefer to visualize or minimize the visual impacts of a retrofit. In some cases, epoxy or mechanical anchors can be used to install in-plane and out-of-plane wall anchorage from the inside face only. The manufacturer might have higher minimum mortar strength requirements than the 30 psi that's required for the alternate method or an ASC 41 retrofit, so testing to demonstrate compliance is required. The 30 psi minimum that you can use for a ASC 41 retrofit does not apply for demonstrating compliance with manufacturers' requirements. So some other caveats with installing mechanical anchorage is that epoxy can require 3 width of bricks to install tension anchors. And proper installation is extremely critical to the performance of epoxy anchors. That means rotary drilling only and proper coal cleaning are key to the successes. Okay, so now we're down to item 3, which provides the pathway for recognition of previously permitted and constructed URM retrofits for compliance with the new seismic regulations. For demonstrating compliance of a previously designed and completed retrofit, we'll be authoring a report and submitting it to SDCI. The reports are submitted and reviewed by structural plans examiners. And in order for us to even review the reports, the building must have their final inspection passed and recorded as such in the building department's reporting system. Buildings with compliant retrofits will then have their status in the database changed to retrofitted. And the reporting requirements will be detailed on the URM program website with instructions for how to submit the reports to SDCI by November 15th when the code goes into effect. So first, subsection A covers the substantial alterations that were permitted between September 16th, 1996 and April 24th, 2009, using the 1994 to 2006 SBC and Director's Rule 3296. 3296 included a very long list of approved references, so the engineer needs to go into some significant detail about the scope of work and methodology used for the design. Some of the references that we allowed at the time were the Seattle Building Code, ATC 14, FEMA 178, FEMA 310, FEMA 356, ASE 3103, and 4106 for retrofits that would be later in that time period. So a structural engineer must review the drawings and sign and seal a report. And that report needs to include field verification of the retrofit and an attestation that there's no significant deterioration of the retrofit work or the building in general. And there'll be a written summary of the fourth level used, evaluation procedure, and scope of work. Typically, the scope of work will include the basics of wall anchorage, diaphragm shear transfer, out-of-plane wall bracing, and parapet and appendage bracing. Supplemental lateral systems may also be evaluated if they were required as a part of the retrofit. For substantial alterations that are a little bit more recent, permitted after April 24th, 2009, using Director's Rule 7, 2009, the building owner or the representative can submit the report without a structural engineer's involvement. We're also allowing a structural engineer to be the owner's representative if that's something that the building owner is more comfortable with. More limited documentation is required. We'll be publishing a standard form on the website that will require the building address, SDCI permit number for the structural retrofit work, and SBEs should be able to verify that structural plans engineers should be able to verify that the building retrofit is recorded as final inspection passed. And you can see a little snippet there in the bottom left corner of what the information looks like in the Seattle Services portal. If you just search for the building address, you should be able to find a building final inspection noted as passed with the record number. And that information, along with some photographic evidence of the completed retrofit work that was submitted along with the form, would be sufficient to get a newer retrofit noted as retrofit, a building with a newer retrofit noted as retrofitted on our database. The final category in subsect C is voluntary retrofits permitted prior to the 21 SEBC. They're not guaranteed to be deemed as compliant, and voluntary retrofits may be incomplete or designed to a lower level of life safety. We try to work with building owners and engineers on the designs, and in the past when they were doing voluntary retrofits, and so there's a possibility that a retrofit that was done on a building may not meet every item that we're looking for to document compliance now. And the burden for proof for compliance rests with the building owner and the engineer submitting the report. Some of the retrofits that we would possibly include as being marked to be retrofit compliant would be voluntary retrofits using the reduced seismic forces similar to a substantial alteration using Appendix Chapter A1 or an ASE 41 Tier 1 or 2 retrofit. The draft URM retrofit technical standard going back to 2012, also known as the Bolts Plus in the design community, and the more recent Director's Rule 6-2023. I'd say that one's probably going to be the most easy for us to check off of the list because it's more recent, well-defined, and easier to follow because of its explicitness. Okay, so we'll get back to the original question that I started the presentation with. I have another video. This building's the same configuration as this first video, but this time it's been retrofitted with diaphragm anchors, wall bracing, and first floor moment frames. So this would essentially be a probably an alternate method retrofit. And the two views here are from the front and back of the building. And I think the accelerations in this one are similar to the strong backed wall demonstration at 1.33 G. You can see some pier rocking, failures of the parapets, and some of the spandrel beams starting to come apart on the back side of the building. So you can see here, even with a retrofit that we would recognize as retrofitted in the new code, the damage to URM portions of the building after a seismic event can still be substantial. The goal here is to reduce loss of life and the time to repair after a seismic event. And now I'm going to pass this over to Amanda so she can provide a few programmatic updates for people who weren't part of the presentation yesterday. Amanda?
Yep, thanks, Derek. So I'm going to begin wrapping up the presentation so we can move into the Q&A portion. But first, just reviewing some of the updates. The biggest update that we've shared thus far is that the new 2021 Seattle Existing Building Code will be effective November 15th, and this will codify the pathways to be recognized as a retrofitted URM and define the minimum retrofit standards. This is decades in the making, so it's kind of exciting to celebrate this. Another key update we haven't yet talked about, I did talk about it a bit in yesterday's presentation, is the reorganization of our website to better answer your questions and to more effectively provide updates. If you Google URM and SDCI, you'll get to, that's the easiest way to get to our webpage. There's a new FAQ page. There's a menu on the left-hand side, and that provides answers and links to resources. If you have suggestions for other FAQs that should be on there, feel free to reach out and we can add those. Our project documents page now contains a link to a new construction pre-submittal conference seismic retrofit questionnaire, which is a lengthy title for a document, but it's meant to help you determine if you qualify for use of the alternate method. And it's suggested that you complete that form and bring it with you to your construction pre-submittal conference. And the website also includes information for how to sign up for that pre-submittal conference. Another update on our project documents page, the procedure to appeal URM determination for building owners, those that are contesting their URM designation, has been updated, and it now reflects the new code definitions as well as gets rid of some old references to our department as DPD. So those were some updates. We have a few things coming soon, so some more updates in the pipeline. We have a goal of November 15th, and we hope to publish the procedures to demonstrate retrofit status of URM buildings. This document, once published, will clarify reporting requirements as well as the submittal process for getting that information to us. Lastly, our team has been conducting permit research to update our URM database, and there's been several demolitions and permits that have been filed that aren't currently reflected in our database. So we intend to update that PDF of our URM list or URM database to be more descriptive of what retrofit status means, as well as to begin tracking code compliant retrofits. And on the next slide, I have an image of a sample of what our future database could look like. We call it our URM database. Publicly, it's often referred to as the list, but it's currently published monthly as a PDF on our webpage. And the buildings that are contained in this database were identified by SDCI as having URM bearing walls. So currently that PDF has a title, as a column titled risk category, and that title is going to be changing to vulnerability classification. For the last few years, that's what we've called it, or what we've referred to it as in presentations. But the reason we're changing the title there is to avoid confusing terminology with risk category, which is very different when you're looking at a building's risk category as opposed to their URM status. I will just a reminder, I guess, that designation of vulnerability classification is linked to future compliance timelines, which have not yet been finalized. That designation is determined by the building's height, occupancy type, and vulnerability to liquefaction, landslide hazards, and steep slopes. We're adding columns to our database to publicize or to show those hazards just for to improve transparency. Lastly here, there will also be changes to the database's display of retrofit level. Retrofitted URMs, so those demonstrating compliance with section 305.4, can have their status changed to a Y or a yes for compliant, and then the adjacent column will document the way in which they met that requirement. So whether it was a subalt, the alternate method. So that is all coming soon. And then I will just lastly add that buildings demonstrating that they were incorrectly labeled URMs can be removed by the list from by an appeal. And I mentioned we have a document that on the project documents page that describes that procedure to challenge the URM building designation. I'll highlight here that the burden of proof is on the owner or the owner's representative to demonstrate that the building does not have URM bearing walls. And it requires a report prepared and signed by a structural engineer, and that would be submitted to our department via the land use analysis request in the Seattle Services portal. There is a fee associated with submitting that, and that fee will be refunded if the appeal is granted. Moving on to our last couple of slides here. We acknowledge, we understand how complicated a lot of these processes may be for building owners or for their representatives, and we are here to help. Our department, SDCI, is offering free 15-minute coaching sessions with one of our URM engineers. To schedule that, you can email our new group email, sci_URM@seattle.gov, and we can get that set up. Filling out that questionnaire to determine whether you qualify for the alternate method. If you have questions on that, that's a good opportunity to utilize that free 15-minute coaching session. If there are bigger questions that can't be answered in 15 minutes, you're always welcome to sign up for the construction pre-submittal conference, and there's instructions on the on our webpage how to complete that application to schedule that meeting for URMs to make sure that you've got one of us on that meeting. Lastly, I will say SDCI has partnered with the Seattle Office of Economic Development to provide permit coaching and expedited services for small businesses. Their contact info is listed on the bottom bullet on that slide, and you can reach out to them to determine if you qualify. So this is our last slide, and then we can move into questions and answers. Before completely opening it up, just some prompts that you may want to consider. Understanding there was a lot of information thrown at you today. If you have recommendations for aspects of today's presentation that need more trainings, we would love you to put that in the chat or send us an email. If you have preferred methods for getting or receiving education or trainings on these topics, we'd love to hear that as well. We obviously want to be respectful of everyone's time and want to make sure we're getting information to you in the best way possible. And lastly, if you're currently experiencing any issues with permitting a URM retrofit, we're interested in hearing that so that we can update and improve our processes internally. So with that, feel free to put your questions in the chat, or if you raise your hand, I can unmute you and you can ask it verbally. I do see there is already one question in the chat. Derek, are you okay with answering that?
Yeah,
Can you see
yeah,
it?
I'll read that now. So the question is, if I understand correctly, a building retrofitted to the alternate method would be deemed in compliance and would be shown as such in the Seattle URM inventory. Are schools eligible for the alternate method? And are there any limits on the use of the alternate method based on occupancy or use? So first, yes, the understanding is correct that a building retrofitted to the alternate method would be deemed to compliance, and we would change the status to retrofitted, and it would be a retrofitted under item 2. And then schools are eligible for the alternate method. They fall under risk category 3. And we made the decision as a department that we wanted to extend the ability to retrofit with the alternate method to school structures in the interest of having as many buildings as possible retrofitted and mitigating the worst hazards. This kind of falls into what I was mentioning earlier about trying to have a conversation between the AEC community and the building department and the owners to encourage going beyond the minimum standard. But if a school owner or school system wants to retrofit their buildings and they can do the alternate method plus a little bit more, that's great. We want some retrofitting more than no retrofitting, especially in lieu of this being a mandatory requirement. So while it's voluntary, you want to get as many buildings retrofitted as possible, particularly because it is a public safety hazard. And then the last part of the question, are there any limits on the use of the alternate method based on occupancy or use? Only if you fall into risk category 4. So that's the highest risk category classification, usually reserved for buildings that are expected to be fully operational after an earthquake, like a fire station or something. And then there's a question about, I work for a seismic retrofitting company. Is there a referral list that I can be listed on? This is something that we're talking about internally about whether or not we can do referrals for retrofitting companies, contractors, engineers, architects that are well versed in seismic retrofitting, particularly with URM buildings, because they are such a unique challenge. There are some complications with regards to conflict of interest and the city showing preference. So it's just something that has been done in other cities for certain types of projects, and it's something we just need to work out the details on. Amanda, do you have anything to add on that?
I think you answered it well. I will just add, we are working on a grant application right now. It'll be a couple years out, but we're hoping to host like a retrofit fair, if you will, that would invite the design professionals, along with lending companies, insurance companies, et cetera, to set up booths, and then invite URM owners to that. So we would open that up so that if you are a seismic retrofitting company, you could attend that and at least solicit building owners that way. Any other questions? I don't see any hands raised.
Okay, so there's a new question in the chat about if there's economy in approaching a URM retrofit by accessing every other story to apply upgrades where possible, and if there's any allowances for installing diaphragms from the underside of the framing. So yes, it is possible to do a retrofit in phases. When I was working in design, I did retrofit a building to what was then known as the Bolts Plus procedure, and they did it apartment by apartment when residents moved out and when they were able to shuffle people around the building, and it was a multi-year process. But as a building department, we do work with applicants to extend permits beyond what would normally be the open window of a permit to facilitate phased installation. And then any allowances for installing diaphragms from the underside of the framing that one's really up to the engineer doing the design. We're not limiting how these retrofits are done. We're just providing a list of requirements for what you have to meet. So if you're able to install out-of-plane bracing and develop it into the diaphragm from the underside and meet the architectural requirements of the building, that's certainly something that we're open to. And if anybody wants to ask a question verbally, I believe there's like down in the bottom middle, there's a little hand you can raise, and we'll get a notification and we can unmute your mic.
Right, not seeing any other questions. I think we can stop recording and